In this task here, we want to compare two proportions with each other. And here's a nice example. So let's say, for example, in population 1, we find 130 individuals with a particular trait, for example, a color. And these 130 specimens are taken of a total sample of 382. So that's population 1. And we want to compare that actually with a population 2, where we pick 77 individuals with that trait, like color, out of a sample of 196. And we want to know whether the proportion of this trait is the same in these two populations. So we can use a whole set of equations here. But first of all, we really need to state a valid null hypothesis. And in this case, the null hypothesis, we could formulate this as, say, H null would be, so H null, that's our null hypothesis. And that would be the proportion in population 1, and I abbreviate that like that, is the same as the proportion in population 2. We can't directly compare these proportions from the samples because, they could be slightly different due to sampling error. But if we do the detour through the population, then we can make comparisons. Now we've got a null hypothesis. We can also formulate an alternative hypothesis where we just simply say the proportion in population 1 is not the same as the proportion in population 2. And we would also specify a criterion when we would reject the null hypothesis, and we would reject the null hypothesis if the p-value that we calculate was smaller than the type 1 error or significance level, alpha, which we have been given here. We set this to 5% here, so 5%. And if we find that the p-value that we then calculate with this equation here, if this is smaller than alpha, we would reject the null hypothesis. And you remember, if p is low, then h0 must go. So this is our rule that we use, and now we can calculate the p-value, and we have to do that sort of stepwise. We calculate the p-value with this equation here, and for that we will use a normal distribution. And the normal distribution takes a z-score, and it is standardized, so the mean of the normal distribution would be 0. The standard deviation of the normal distribution would be sigma 1, and this parameter true indicates that we are cumulative. So that is our equation for the p-value. Now we need to calculate the z-score, and in order to do that we need to calculate the proportions and a combined proportion, and the combined proportion can be done with this particular equation. So let's just simply try to make a start. Let's calculate the proportion 1 here, the first proportion, and that is the success. That is actually the number of individuals with this particular trait in the total sample of this population. So here this would be equals 130 divided by 382. So that's the first proportion. So 34% of the individuals in population 1 have actually this particular trait. And we do that for the second population. So we've got 77 divided by 196. And we've got 39%. So we see there is a clear difference between the percentages when we look at the sample. But the question really is there a difference when we look at the populations? And in other words, is this just simply this difference that we observe? Is this just simply due to sampling error? Now we also need to calculate the combined proportion. So for that, we add up the success. So we add up the success. 130 plus 77, and we divide it by the total number of the sample sizes. Okay, so that gives us the combined proportion. Now we can calculate the z-score. So let's get started. Equals. We need to take the absolute value of this difference here. So absolute value of the difference between the proportion 1 minus the proportion 2. So that's our numerator here. And now we divide it by the square root. And for the square root, we have the combined proportion, that is what we just calculated, times 1 minus the combined proportion times 1 over the first sample size plus 1 over the second sample size. We close this bracket, so this bracket here is closed, and we close the last bracket, so that would be the square root bracket, and hopefully we will get a reasonable value. So we get a z-score of 1.24, and we now need to look at this z-score and compare it with a normal distribution, and we can use now this equation here to calculate the p-value. So we've got equals 2 times, open the bracket, 1 minus norm, and we are looking for the dist function, norm dist, that's this one here, and we include the z-score, that's the first argument, that is what we just calculated. We have 0 for the mean, we have 1 for the standard deviation, and we want true for the cumulative, and we have then 2 brackets here. Okay, and we get a p-value of 0.21. So p equals 0.212. And we now compare our p-value that we just calculated with alpha, and we find that this p-value is certainly larger than alpha. Alpha was 0.05 or 5%, and therefore we cannot reject the null hypothesis. So we would fail to reject the null hypothesis. In other words, we would say that the difference in the proportion here, that we see is just simply due to sampling error. And there is actually no difference between the two proportions. No difference between the two proportions in the different populations. So that is how we can do this calculation in Excel, but I appreciate it's a little bit tedious to do all these calculations. We can also use a really good online calculator. So here's my favorite online calculator, and I put the link to it in the description to this video. So what we can do is we just simply put in the sample, the success, and the number of the sample size. In this case it's called trials. So we had 130 out of 382 for the first population and 77 out of 196 for the second population. We get the confidence intervals here for the proportions, and we also get a value here for the p-value, and here it calculates p-value equals 0.21, and if you compare that to the p-value that we calculated, we got a 0.21 as well, so that very nicely tallies. And we also even get the message that there is no significant difference between the proportions of these two populations. So this is how you can calculate the or check whether two proportions are similar, either with Excel or with an online calculator. I hope this makes sense, and thank you very much for watching.